added together. 12 plus 18 is 30, plus 12 is 42. Its area, so that's going to be in square units. Again, if I lost you anywhere, please rewind and watch it again, post questions on the discussion board, or come to tutoring. So for 916, Paul built a tower by stacking 6 identical layers of the shape below on top of each other. What is the volume of his tower? So if there are 6 identical layers, this is your key here, 6 layers. So here's one layer, and here's the tower. So if you want to sketch out where the 6 layers would show here, you can do this with dimension 1, 2, 3, 4, 5, 6. Give this some dimension here so you can show exactly what you're looking at. Those of you who are artistic will probably really like this activity. You can sketch these out. And you see that I am not very artistic. Okay, so the volume of this. Well, each layer is going to be how many blocks? If you want to pause this and try to answer these questions on your own and then unpause it and see if you've got it, that would be a great idea to see if you really know what you're doing here. Okay? And I have drawn another line down here to kind of separate this into cubes in my figure here. So the volume of one layer, 1, 2, 3, 4, 5, 6, 7. If there are 7 cubes in each layer, and I've got 6 of those layers, then I've got 7 times 6. 7 times 6. So 7 in each layer times 6 layers. Times 6 layers will give us 42 cubic units for our volume. Okay? And this is the way volume is going to work for every single structure that we work with. We're going to be finding the area of the base and multiplying that times the height. So the area of the base was 7 units, and we multiplied that times 6 layers, and that gave us our volume. It's going to work on every figure we work with. The surface area is going to be a little bit trickier because for this structure, we have a hidden side. What I mean, or we have a couple of hidden spaces. What I mean by that, here's a layer of Paul's tower, by the way. We can see the top and the bottom are pretty straightforward. 1, 2, 3, 4, 5, 6, 7. Okay, and on the bottom, 1, 2, 3, 4, 5, 6, 7. Where it gets kind of sticky is the front and the back. So the left and the right are pretty straightforward also. We have 1, 2, 3 on this side, and we have 1, 2, 3 on this side. This is for each layer. And the front is pretty straightforward. We have 1, 2, 3. But when we turn it over and look at the back, we have 1, 2, 3. But we also have to consider these trapped or hidden layers in a structure such as this. Okay? So the surface area is going to be a little bit tricky because of that. So the surface area. We have a top and a bottom. And we know that the top and the bottom are 7 units each. So that's 7 plus 7, which is 14. Okay? We have a left and a right. Okay? So the left and the right. If this was the front, the left side's going to have 3. The right side's going to have 3. But it is 7 layers tall. So if there are 3 units on the right, times 7. So there's 21 on the right and 21 on the left. If I lost you there, please rewind and watch again. Okay, so for the left and the right, that is 42 units total. Okay? Now we have the front, and then we have the back, which is going to be different because of those hidden sides. The front is just 3 per layer, and there are 7 layers, so the front is just 21. When it comes to the back, we've got 1, 2, 3, 4, 5. We've got these hidden faces. So we have 5 on each side of the back, and there are 7 layers. So 5 times 7 is 35. So now we've accounted for all of our faces, and we simply need to add them together. So we have 14 plus 42, which is 56. 56 and 21 we should probably do this in pieces here. This is 56. 56 plus 21 is 77. And then 77 plus 35 is, what, 112, I believe? 7 and 5 is 12. Carry the 1. Yep. Okay, so we have, for the surface area, we have 112 square units. Okay? Now, Paul's tower is an example of a prism because it is a solid and two of its faces, called bases, are congruent and parallel. A prism must also have sides that connect the bases, which are called lateral faces. So, for our tower here, notice that the top and the bottom were rectangles, and all of these sides, front, back, left, and right, are called lateral faces. So each lateral face must be a parallelogram, and thus may also be a rectangle, rhombus, or a square. For each of the prisms below, find the volume and the surface area. This would be a great place to pause the video and check yourself. See if you can get these, and then come back to it and see if you got what you thought, or see if it was what you thought. Okay, so for this first structure, we have 1, 2, 3, 4, 5 layers. Okay, that's our height. And each layer is 1, 2, 3, 4 blocks. So if we have 4 blocks times 5 layers, then our volume here is 20 cubic units for the first one. Let's look at the volume of the second one. Here we have 4 layers, so 4 is our height, and each layer has 1, 2, 3, 4, 5, 6 cubes. So our volume here is 4 times 6, which is 24 cubic units. And for number 3, again, we have a height, which is 5, and the area of our base, I'm going to go ahead and sketch this out, because it is a rectangle down there. It is a 3 by 4 rectangle. Give it a little bit more dimension here. The 3 by 4 rectangle has an area of 12. So 12 times the height of 5 gives us a volume for this one of 60 cubic units. So now we just need to tackle the surface area. So we can do this in terms of top and bottom. I'll just call that T and B on these other ones to make this go a little bit quicker. Top and bottom, we have left and right. I'll just call that L and R for the other two. And then we have front and back. I'll call that F and B for the other two. Just don't confuse the B's. This one means bottom, this one means back. Okay. So we are looking at surface area here. So our top and bottom are 4 and 4 for this first structure. 4 and 4 is 8 units. Okay. Then our left and right. We have, for the left we have, or for the right, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 15 on the right. There will be 15 on the left as well. So our left and right is 30 units. Now for our front and back. For our front, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we'd have another 10 on the back. So our front and back together is 20. So when we add up all of our units here for surface area, we get 58 square units for our first structure. Same situation on our second one. And if you haven't yet, this again is a good place to pause the video and see if you can do the surface area for these other two figures. See if you've got it. Okay, so our top and bottom for the second one. For the top, we have 1, 2, 3, 4, 5, 6, 6, and then we have 6 again on the bottom, gives us 12. For our left and right, it's a little bit hard to see here, but on the right, we can see we have 1, 2, 3, 4. You're going to have another 4 down this side, another 4 down this side. So 4, 4, and 4 is 12. You're going to have another 12 on the other side. So you have 24 for the left and the right together. And then the front and back. The front, you've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Another 12 on the back gives you 24 here. Adding up all of those faces, you have 20, 40, 50, 60. Okay, so you have 60 units squared here. I got 20, 40, and 50, and then I knew that 4 plus 4 was 8, plus 2 is another 10. So that's how I got my 60. Okay, so for our top, bottom, left, right, and front and back here, I can see that my top and bottom are 4 by 3 rectangles. So 4 times 3 is 12. 12 on top, 12 on bottom gives us 24. Now for our left and right. Our left and right are 3 by 5 rectangles. 3 times 5 is 15. 15 and 15 gives us 30. And for the front and back, since this has a height of 5, then our front and back are 4 by 5 rectangles. 4 times 5 is 20. And again on the back, 20 and 20 is 40. So adding up all of our faces, 40, 70, 80, 90, 94 units squared for our surface area of that third one. So if you tried it and then checked it, hopefully you were able to get those. If not, feel free to post questions on the Canvas discussion or come to tutoring if you have any. So our last two problems here are little challenge problems, which we'll work through quickly because we've already done the core problems for this section. Heidi created several more solids represented below. Find the volume of each one. So we're just looking at volume here. Well, this is a mat plan, so all we need to do is add up the numbers, and we'll have the number of blocks here. So we have 22, 18, and 16. I'm going to add these up in rows to make this a little bit easier. So this is 8, 9, 10, 16. Carry my 1, 2, 3, 4, 5. I have 56 in this first row. In the second row, I've got 10, 20, 30, 35, and 40. And in my third row here, 25 and 30 and 38. So I have 56 plus 40 plus 38 blocks. 56 plus 40 is 96 plus 38. See, 90 and 30 is 120. And then I have another 14, so 134. This is volume, so we are in cubic units. Okay? All right. So looking at part B, this is a structure that you would fold up. So if I folded this up and around, then I would have a structure that had a base. Let's say this is the base. The base is 3 by 4. Okay? And when I folded these flaps up, it would be 2 units high. So for my volume here, I've got a base that is 3 by 4 units, and then I have a height of 2. 3 times 4 is 12, times 2 gives us a volume of 24 cubic units. C is a little bit trickier. Kind of looks like a Rubik's Cube, if y'all have seen one of those. But notice that this one is not shaded in the middle, so there are 3 blocks that do not exist inside. Of course, you can't see all the way down there. Maybe it's just 1 block that doesn't exist. So this is kind of a matter of opinion on this one. But if you did the entire structure, then you would have a 3 by 3 bottom and 3 units high. 3 times 3 is 9, times 3 is 27. But then if you subtract out the 3 that are missing in the middle, then you have 24 units cubed. So not knowing if that is 1, 2, or 3 cubes missing, I would take 24, 25, or 26 as an answer on this test because you could make an argument for any of those. Okay, looking at 9-18, Pilar built a tower by stacking identical layers on top of each other. If her tower used a total of 312 blocks, and if the bottom layer has 13 blocks, how tall is it? This is just like Paul's tower. We're just working it a little bit backwards. We know that the total volume is 312. And we know that volume is the height of the structure times the each layer. So the area of each layer. Which is the base. Okay? So here we know that we're looking for the height. This is asking us how tall the tower is, so we're looking for the height. And it tells us that the area of each layer is 13 blocks. And we know that the total volume is 312. So 312 equals 13 times h. So to solve this, we're just going to divide both sides by 13 to get our height. So we can do this division to the side here. See, 13 times 2 is 26, 13 times 3 is 39.